Hello and welcome. This is going to be the homework help video for the linear inequalities homework. Let's go ahead and get started with problem number 1 here. We need to sketch a graph of the linear inequality. So I first check that this is in y equals mx plus b form. It is. So I can just put a point right at my y-intercept of 4. And then I need to find a few more points. I'm going to use the slope to do that. This slope is 7 over 5. So think of that as rise over run. I want to rise 7 and go 5 to the right. But if I do that, I'll go off the graph. So I'm going to reverse it, and I'm going to go down 7 and then left 5. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. All right, and now you can tell to get from this point back to this point, I would rise 7 and run 5. Now that I've got as many points as I can get on there, I look at the inequality symbol. This one does have that or equal to. So I want to connect these 2 points with a solid line. So let me pick a solid line here. Connect those 2 points. All right, the solid line means that points exactly along this line will be considered solutions to this inequality because of that or equal to there, and to make it exactly balanced. Now I need to shade the side of the line that has more solutions to this inequality. This is a less than symbol, so I think less than lower. I go below the line, go to any point of that line and just go straight down, and you're on the lower side. All right, and now I'm shading all of the ordered pairs that are going to make that inequality true. All right, and we can check with some of these ordered pairs. Maybe we check with 0, 0 because it's in the shaded region. Is 0 less than or equal to 7/5 times 0 plus 4? Well, anything times 0 is 0. Is 0 less than or equal to 4? That's a true statement. So it checks out. All of these points over here are going to lead to true statements. All right, let's look for one that maybe is a little bit different. Maybe number 4. Y-intercept of -4. Slope is 8, so I want to turn that into an 8 over 1 so that I can do rise over run. I'm going to rise 8, run 1. I'm going to connect this with, again, a solid line because it does have that or equal to. And then I'm going to shade, this is a greater than, so I'm going to shade above. So I'm going to go to one of my points, go straight up. I'm in the above region. I can start shading up here. And you want to shade pretty lightly. That's going to be useful when we start doing systems of these. So just get in the habit of shading somewhat lightly. Also, if you need to go change your answer later. Let's double check again with the origin, because that's within our shaded region. Is 0 less than or equal or greater than or equal to -4? It checks out. Let's do 6, because I can tell it's going to have a dotted line already because it doesn't have the or equal to. I put a point on my y-intercept of 5. I go down 10 over 1 because of that slope. I'm going to connect these points with a dotted line. All right, now which side of this line am I going to shade? Well, that's a less than, so I'm going to shade lower. So this being dotted means that those points exactly on the line are right on the boundary of what makes this inequality true. Those points are going to lead to statements like 5 is less than 5, for example. So that's not an entirely true statement, but right up to that line, we have ordered pairs that make the inequality true. Okay, number 7. What's my slope? What's my y-intercept? I can't tell right away. I've got to use some of the white space to change this into slope-intercept form. So 6x plus 7 is greater than 2. Move that 6x over to the other side, and I get y is greater than -6x plus 2. Now I've got a y-intercept, I've got a slope. I can connect these up. This time I pick a dotted line. And I'm looking at this one to decide whether I shade above or below. This is a greater than, so that means shade above. All right, so we look at our manipulated equation to determine shading, not the original equation. Okay, what about number 8 here? Same thing, I need to write it off to the side. get it into slope-intercept form. I subtract x from both sides. I get negative y is greater than or equal to negative x plus 5. I'm going to get rid of that negative, so I divide by negative 1. Here's where hopefully you remember something about inequalities. I divided by a negative. I've got to flip the direction of that inequality. Y is less than or equal to x minus 5. Now I put a point at negative 5. My slope is a 1. It's an invisible 1, so that means go up 1 over 1 all the way across the graph. All right, connect them up with a solid line. Very good. And then we look here to determine shading. This is a less than, so we're going to shade lower on this one. All right, and double check. But we'll double check. When we double check this point here, I'll pick the point 4 comma negative 5. I'm going to plug it into the original equation to make sure I didn't make a mistake somewhere else. 4 minus a negative 5 is greater than or equal to 5. 9 is greater than or equal to 5. That is a true statement. The alligator is eating the bigger number. Okay, what about just x is less than 0? Well, x equals equations create vertical lines. So I can do a vertical line that hits the x-axis at 0. This needs to be connected with a dotted line. So I'm going to pick a dotted line. And then when it's less than, you're going to shade to the left. Think less than left, or just this points the direction to shade. All right, and we can double check these too. Just because it has one variable doesn't mean we can't double check. If I pick a point over here, negative 3 comma 4, and plug it into my equation, well, I'd only be able to plug in the x. I'd get negative 3 is less than 0, and that is a true statement. You'd rather have $0 in your bank account than negative $3 in your bank account. Okay, let's do 11. 3x plus 5y is less than or equal to 15. I need to get this into a slope-intercept form, so 5y is less than or equal to negative 3x plus 15. Divide everything by 5. Y is less than or equal to negative 3/5 x plus 3. Just because this is negative doesn't mean anything flipped. When I divided by a positive, which means don't flip the inequality. All right, pointed at my y-intercept of 3. I go down 3, right 5, or up 3, left 5 to get 2 points that are on that line. I'm going to connect them with a solid line. And then I'm going to shade. I look here, I shade below. All right, y is less than or equal to negative 1. So let's dot in the line y is equal to negative 1, which would be a horizontal dotted line, or just a horizontal line. We're actually going to end up connecting this with a solid line because it does have the or equal to part. And then we're going to shade below. Okay, call that good for this homework help video, and have a good rest of your day.